Thank you very much, Maxime. Thanks everybody for coming here. It's a pleasure to be back again in Norway, in Oslo. I was talking with Maxime before that I visited the Mobile Era. I think it was a couple of years ago, same venue, and yeah, always good to be here, except for the prices. And today I will be talking about Kotlin native for mobile citizens and mobile developers. Not only Kotlin native itself, but also everything that goes around a new technology, which is, in our case, is the ecosystem, libraries available, etc. Very shortly about me, I'm a freelance developer. I'm originally based in between Munich and Vietnam, originally from Spain. I'm a member of the Google Developer Expert community in Kotlin and Android. I'm also the manager of the Kotlin weekly mailing list. So if you write any article on Kotlin or anything that has any relationship with Kotlin, reach out to me and it will be a pleasure to send it through. This is my Twitter handle if you want to ask me any question. And I'm mainly doing now Android Kotlin, backend Kotlin, and iOS, mostly with Swift. So first, what's the motivation when we are talking about multi-platform technologies? The main thing that might came in the mind of many managers is that the costs are being decreased when we're using something that is multi-platform, because the principle is that we code once and we deploy it several times, which can sound appealing when you are dealing with a budget, but I believe we should target this towards having a higher quality. When we have a multi-platform solution, we have a single code base rather than several one, and this can help us quite a bit to tackle things like bugs, complexity, keeping the team focused in features instead of spreading them through different SDKs, frameworks, languages they have to develop, etc. In fact, this leads to something interesting, which is having code shared within the company. If you've been developing apps, you generally have sort of a mobile app kit where you have maybe your network requests, your models, etc. This could be, if this is written in one language, this could be easily shared among the entire company. So we don't need to have one for iOS, one for Android, one for the web, etc. And something that I've seen in a few companies is that teams can focus on features instead of focusing on the technology. So you will end up with a team that is working on the payment module or a team that is working on the login module. You target them on the expertise for the particular thing they develop rather than the technology itself. And you have one technology stack. It's hard to find senior developers nowadays. I'm not saying that Kotlin is easier than other solutions, but you can focus your company on one particular technology stack rather than spreading too much. In fact, I heard an interesting story now coming to the current state of the art, and well, we have, this is the current state of the art on multi-platform development. We have the platform proprietary solutions, Xcode or, well, Java Kotlin for Android, hybrid HTML and JavaScript frameworks, and cross-platform natives such as React, Xamarin, and stuff. What I was mentioning before is that there seems to be an argument for these multi-platform frameworks. And in the case of React, it's widely used in a few regions in the world, such as, well, India, Vietnam, etc. And apparently it's because it's easier to find JavaScript developers. You can develop in JavaScript and develop for mobile, whereas finding a senior Swift developer in some regions can be an impossible mission. So many companies seem to be adopting those frameworks just to be able to hire people on an acceptable basis rather than having openings for months that never get fulfilled. Well, why Kotlin? Coming to the top of the solutions that already existed. This is a mobile conference. I assume all of you are at least familiar with Kotlin. Kotlin is a modern language. If we compare it with the direct comparison we have, which is Java, Java was born in 1995, so that makes it 24 years old. It's a very decent age for a language, considering how this world evolves. It sounds even like prehistoric. In the case of Java, there was also a few little problems. And, well, Java, as you know, is now property of Oracle. Oracle moved from being a tech company into a copyright company. Now the main business of Oracle is to acquire companies and sue other companies for the use of the previous company. And that's what they've been doing with Java. So one of the reasons why Google cannot move much more in the Java version they're using is that they're facing massive problems with Oracle in terms of copyright. In fact, somebody at some point vandalized the Wikipedia and changed the list of largest law firms by revenue and included Oracle at the top. So I guess it depends on your perspective, but that has been a thing in the Java and Kotlin, or has been one of the motivations for the arising of Kotlin. Kotlin, as you know, it can interoperate with Java fairly easily. We also have a Kotlin transformer tool that allows us to take our former Java code and convert it into Kotlin. Relatively straightforward. It's not a solution that works 100% of the time, but is getting quite close. It has a lot of community support. Today, a language is not only the language itself. It's obviously everything that is built around that. Obviously, you have languages that are technically excelling, such as Rust, Elixir, but they lack this community support. In the world of Kotlin, we had a lot of enthusiasm from people that was previously developing for Android, Java. Then they saw that Kotlin was going to be the next big thing for Android. They have been developing all these libraries around it. And we have a lot of solutions for all the reactive frameworks, database management, networking, etc., that doesn't exist in other languages. I'm not particularly looking at Flutter, but but yeah, it's very important. It has top-notch tooling, so Kotlin is done by JetBrains. JetBrains is the company behind Android Studio, or behind IntelliJ. Android Studio has been adapted from IntelliJ. And they're really good at developing software for software developers. In fact, there was this thing that Appcode was able to refactor Swift, while Xcode was not able to refactor Swift. So that's how good they are. The good thing with sharing is that sharing is optional, and there is no life or death commitment. The fact that you jump into Kotlin native doesn't mean that you are going to be doing Kotlin native for your entire app and stop doing the native development. You can share it, you can do it with the small modules, and you don't need to break anything you were doing before. This is the current state of the art. In the last Kotlin Conf, in the last quarter 2018, the version 0.9.3 was released, which included the IDE tooling and the coroutines in Kotlin native. Now there has been a weird movement, and is that Kotlin native moved from this 0.9.3 into the same version as Kotlin. So the version from Kotlin native now is 1.3.53, I think. But it doesn't make it stable. It's still something that has been integrated now within Kotlin itself, but it's not stable. In 1 month, I think, or in a few weeks, there will be the Kotlin Conf 2019, and it's very likely that they will be releasing a new version of Kotlin native and probably announcing something that makes it a little bit more stable. Kotlin native came from Kotlin Anywhere. That was the primigenial idea behind it. JetBrains realized that, well, they were doing a lot of server code with Kotlin that could be shared with Android and with the browser as well, as other tools such as GWT was doing. So you could code in GWT on your Java code, you could transpile into your JavaScript and show it in the screen. So that's how it started. It evolved a little bit further, and the approach that JetBrains followed was, well, we could have a common module that will contain the definitions and the common functionality, and then a particular module for each architecture. In our case, as mobile developers, the relevant modules are the JVM for the Android platform, native for our iOS app, and then JavaScript as a different subset, because JavaScript follows a little bit of a different process. It transpiles, it doesn't compile, but the principle is the same. So we would have our native module that compiles into an iOS framework, and this iOS framework gets integrated into Xcode, and the Swift or iOS developers can access it. In the case of Android, it compiles into an Android Java library that every Android developer can use. One remarkable thing about Kotlin native is that this is about sharing the architecture, not the UI. Why? Because Google doesn't care about iOS UI, Apple doesn't care about Google UI. In fact, if you check an iOS, an iPhone, and an Android, the patterns are very different, the usability, the clicks, the visual identity from components, so it would be really hard to make this generic. But if you think underneath this, all the apps are the same. The principle is that you have an app, it connects to an HTTP endpoint, REST API, it holds some JSON data, takes the JSON data, serializes it, puts it into a database, and operates with it. Apps are doing the same regardless of whether they are on iOS and Android, and that's what we want to generify here. Mostly about Kotlin native itself, it uses LLVM 5.0. LLVM is a project of a collection of modular and reusable compilers and tool change technologies. It was developed by Chris Latner, the creator of Swift. And it essentially, most of the compilers run now on this technology. It provides runtime guarantees. Things such as exceptions and memory management are provided by Kotlin native. It can interoperate with C and Objective-C or Swift, or the other way around, not with C++. And yeah, there are platform libraries such as POSIX, Apple Frameworks, Win32, DOM, etc. The process is relatively straightforward. We will have our Kotlin source code file. This goes to the Kotlin compiler into an intermediate representation that goes to the LLVM, and then we create the platform binary that we want for our desired architecture. The compiler itself serves frontend with Kotlin JVM and Kotlin JS. It's finally written in Java and Kotlin. JetBrains announced this proudly on their website. And the bit code is produced via the LLVM API. About the memory management itself, it uses the ARC. If you've been developing for iOS, you probably know about this. It's the automated reference counter with a cycle collector. Also, when we are working with pure Kotlin, we don't need to worry about the memory management. This is done automatically. Weak references are supported, and the memory sharing model is something a bit different from what you've been working before. Objects of grabs can be transferred between different threads, but they need to be done sort of an immutable object that we'll see later. It's called frozen object. Otherwise, they cannot be transferred. It can interoperate with different languages, so as mentioned, with C, Objective-C, Swift, and the other way around. The interesting thing here is that with Kotlin, we can call Objective-C classes, and the other way around, we can extend them, which is very useful when we are thinking about sharing code among the company. And Kotlin is aware of the Objective-C memory management runtime. So when we are creating objects, deallocating them, etc., Kotlin is aware of what's happening. The mapping is also relatively straightforward. We will have something like numbers are kept, strings are converted into the destination platform string. The declaration grabbing C entities in Kotlin, things such as function, struct, and unions are auto-generated. And there is an equivalent between the object-oriented concepts in Kotlin and Objective-C. So classes are classes, obviously protocols are interfaces, and blocks get transformed into lambdas. And yeah, as mentioned, Objective-C, for Objective-C, Kotlin gets compiled into a framework. The Kotlin, there is also functionality to create Kotlin libraries, Kotlin native libraries. They are very similar to what a jar file is. The extension in this case is klib and holds essentially all the byte code and the metadata, so things such as when one is compiled, version use, etc. And there is a tool from JetBrains to create and store libraries in repositories. So this makes the process of integrate this with our CI architecture and deploy into a Maven or a pod repository easier. If you want to get started, you need to clone this repository from here. If you Google Kotlin native GitHub first result, you need to update the dependencies. You need to bundle them. I strongly recommend to do it before you take up on any plane, because it can take quite a bit. And it's relatively straightforward. Such as any GCC compiler, you just specify the output and the input, and that's how it works. We can, in fact, run a super small one here. So I'm here inside my Kotlin native repository. And if I type something like hello.kt, this is a hello world in Kotlin. Essentially, we're just printing native world with an interrogation at the end. And if we do something like Kotlin C, let me make this a bit closer. Hello.kt, output example.kt. We would be compiling this on the desired architecture on the file example.oh. Well, example.kt is, normally you would give them something like X or something similar, not example.kt. Do you see any problem now at the beginning? It takes so long to compile. So I think the approach from JetBrains was we are first going to focus on making this first work, and then we'll iterate and make it more optimal. So here we get a warning about the arguments, and if we execute the example.kx, we will print here hello native world. So essentially here we can, this would be like essentially with any other programming language. You just pack whatever you want and gets compiled. Regarding this time, one strategy I've been following, I can elaborate on that later, is to, since with Kotlin native, normally you're packing models and, or that's the idea, or modules that might not be updated continuously. It's a good idea to do it with nightly builds in general, to run all the tests and stuff, because otherwise, right now can create a little bit on a bottleneck of on your process. But yeah, you have to check how this fits on your team. In order to define what's on the common module and what needs to be implemented on the target modules, we use a combination of expect and actual keywords. We'll have, well, this would be a full example. Expect, an expected declaration always goes into the common module, is the what the actual counterparts in each particular target module need to represent. So with exactly the same signature, return type, and stuff. All the actual declarations need to match the expected declaration in the common module with the same signature, return type, etc. Having they're only in the implementation modules, not in the common one. And the expected declarations never contain any code. Yeah, this is how it would, the actual implementation of the full function would work, but it's probably better if we see a real-world example. So what's the first thing we do when we are visiting, when we are creating when we are working with a new language? We create the logger, right? That's the thing that takes not too much and allows us to play with it. So let's gonna think of something like this. We will have something like a debug warning, an error log level that happens in every single platform. And the things we want to do is to write on this message on the console or wherever we write it. And yeah, with all these different levels. So this would be the expected declaration, right? And this is how it would actually be implemented. In the case of Android, we need to use printline or logd or whatever we want. And that's how it would work on the GVM. However, in JavaScript, we have a console object. This console object is the one that is able to access the website, is able to print on the console. So here it changes a little bit. See that we have the same signature we had at the top. We receive the message, we receive the log level, we just iterate over it, and depending on the level that we are receiving, we will use this console object that gets defined by Kotlin and print it directly on the screen. Right now, there are three main actors in the Kotlin native ecosystem. One of them is obviously JetBrains, which is the creator of the language, and there are two other companies, Touchlab and Square. Touchlab is an agency located in New York. They organize the DroidCon New York, and they've been putting a lot of effort in creating awareness of Kotlin native. They've developed as well the Kotlin native plugin for Xcode. One of the things is that in Xcode is well, essentially impossible to debug any sort of Kotlin code because, well, it's not written in Swift, and Xcode is not really aware of the objects created by Kotlin native. And with this plugin, we can actually debug. So it's something very useful. And Square. Square is the company where formerly Jay Wharton, which I'm sure you know or you use some of his libraries, was working. And they are also betting a lot on Kotlin native. We have a few community projects. SQL Delight is a multi-platform SQLite model facilitation library. KnarDB, currently deprecated, and SQLite Access library with an Android-like structure and interface. Multi-platform settings, similar to its, provides a functionality like share preferences in Android and NS user defaults in iOS, if I'm right. Stately, OKIO2 that is currently under development by Square. And there are a few provided by JetBrains itself. One of them is Ktor, which is a client-server networking. Only the client part is currently developed in Kotlin native. Atomic helper, the Kotlin coroutines that you probably or very likely know. They are, however, only single-threaded in Kotlin native, which might push a limitation. And atomic FU. One thing is that Kotlin native doesn't give us primitives such as synchronize or volatile. And JetBrains recommend us to use atomic FU in order to perform atomic operations. Let's gonna go first with Ktor. Ktor is a web application framework. It allows us to create a client decently fast and a server as well. The client can be used right now native. That means web, iOS, and Android. And it's, well, let's see how it would work. We will need to include the dependency. See that the dependency here refers to the client in Android, so they provide one for each particular platform. And this is the one that we would implement in iOS. It just changes a bit the address we would specify on our Gradle or Maven repository. And this is how it would work. In the common module, we could define, for example, a class called application API. This class contains an address of type URL, whatever we want to specify here, and then a coroutine that calls this address, takes the result, and returns it as a string. Of course, depending on which platform are we using, we are going to operate differently with this result. In Android, we maybe want to paint it on a text view. In JavaScript, maybe we just want to paint it on a, I don't know, a button or whatever you use on the web today. And so let's see the example for Android. We will have an, don't judge me, this is just a small example. You normally don't do these things on a real app, but you will have the onCreate method, you override it. You could call directly the application API object. From there, directly call the function about. You receive the string that is returned from the URL. And inside the launch block, you see that we call the find view by ID. We find the ID of that particular view, and then we paint the text that we received. However, in the case of JavaScript, it will work a little bit differently. We will still call the application API class. See, something very interesting is that we can actually change the address from the particular module. So in this case, we will override the address that we're using, specify a different one. And then after calling the function about, we will have this block where we receive the text that is delivered by this endpoint and paint it on a pre-element or whatever we want in the web. See that we have a document object. That document is as well provided by Kotlin native, as was happening with console, and allows us to do things such as create element, create JavaScript, access the CSS from our web page, etc. Coroutines. The coroutines are JetBrains async response. They are a network, an asynchronous mechanisms generally used for, operating on network or making threads where we are accessing our disk database, etc. This is how we would implement it. See as well something interesting, and is that they provide a common implementation. I didn't show it before, but essentially we would. I just realized it's an error. At the end, there is not Ktor version, but coroutines version. But the URL is the same. And they are, very straightforward. You've used them before. We will, in the common functionality, specify the function that is going to be used, then launch it, and here. See that we are actually calling the so-hello coroutine from an actual KT class. That would be the result, the file that results after compiling the actual.kt. That is how we would call those functions. KotlinX.io is a library for IO primitives, building some manipulations. It's still experimental, not final. Again, we'll include our GBM module or however we want. And this happens as a result. I'm good. That's something that we would need to, in most of the apps, right, to make disk operations and being able to write or read flows of data. We could use an object called byte read package, consists of a managed sequence of buffer views. It is read-only. so we cannot use it to write. There is no way to reset already written bytes, so we need to finish, and then everything has been operated, and then we reoperate if needed. And every buffer is released once it becomes empty. If we want to write, we will operate a little bit differently. We will use this byte packet builder. It has a release function that needs to be called explicitly in order to discard all the bytes. Otherwise, we might end up having a memory leak or any problems with memories. And with the function build, there we call it at the builder.build, we create the instance of the byte read packet and reset the builder state. So we can start operating with another package. AtomicFU is the library to do atomic operations on Kotlin. Right now, there are no threading primitives in Kotlin, such as synchronize or volatile. So if you came from the Java world, that might come as a surprise. We need to use AtomicFU instead. Something remarkable is that this is also quite experimental. The version is still not stable. I think it's maybe good enough for getting a glimpse of it, but this could deter from using it into any big app that needs to scale. This is how it would use. We would declare a top variable for a log-free stack implementation. That would be the top over here. We could do things such as volatile read or volatile write with the top variable. And we would also have functions for high-level updates, such as update and get, get and update if we want, for idiomatic log-free code. Now, into database. Well, the solutions right now are the most stable ones, SQLiter and SQLagger. There was originally a library called NARDB, which is sort of deprecated now, or not being developed that intensively from Touchlab. SQLiter is an SQL driver, a low-level library. You can do sort of dangerous things. And SQLagger lets us to kick back and relax a little bit more. It's the one recommended by Touchlab to be used. We would need to create a database instance. We will have this instance object from here, and we will have all the 4 basic interactions with the object. We could insert, update, delete, execute, and do any selects. If we need any parameter, binding parameter, we could do that with a lambda. So see things here such as we would need to specify like a long or a string or whatever we want. We can do it inside the block that is provided to us by insert. If we want to use select doesn't return in a result set, such as if you're used to Room or Realm, they generally return you an iterator and you just operate over it. In this case, we just do it with the iterator inside the lambda. The argument for this from Touchlab is that they want to avoid leaking SQLite statements this way. I actually got to like it, doing it like this. Again, that's probably something that you need to evaluate on your own. Multi-platform settings, share preferences on Android and energy user defaults on iOS, something that we will end up using very soon in any app we are developing. It's funnily developed not by JetBrains or by Touchlab or Square. It's developed by Russ Wolf, a developer from New York, I believe. And well, the library itself is fairly simple. We will have a settings object, and we can write or read primitives into our destination platform. Serialization as well, it's something that we end up doing very frequently when we are dealing with mobile apps. We need to connect to an endpoint, get whatever information, share it, so we can, in the case of Android, share it between different views, store it to this, whatever. It's also relatively straightforward if you've worked with any other serialization platform. I like in this case that they make a really nice, provide a really nice API to deal with JSON and transform between JSON and the data itself and a string. So we will have the function stringify, for example, that returns at the JSON, add the function parse that parse the JSON and creates an object. So as you can see, in a very few lines, you can start operating with strings and JSONs and serialize them. Well, some things to consider. I tend to be, as much as I love Kotlin and Kotlin native, tend to be a little bit skeptic of introducing something into production that is not production ready, because companies are probably going to remember you as the person that took that bad decision. So some things you need to keep in mind. An object only belongs to one thread. It cannot belong to different threads in Kotlin native. How do we solve this? We solve this by freezing objects. Freezing an object makes the object a type of a super immutable object, so not only the object itself, but all the references and the entire tree. And well, I was thinking of, is this concept present in any other language, or did we ever use this sometime before? I came into the conclusion that everything we've done until now, it's not frozen. So it's sort of a new concept, whereas it's better than the previous alternatives or not, I'm not really sure. JetBrains tell to do these things a lot, such as classes are closed by default. You need to specify if they're open. That's something that forces you to change your mindset a little bit. And yeah, that is how it is. Some considerations in state. Runtime safety. Kotlin native can verify safe mutability, which is helpful. And a few other things. So check out this login view model. This is something relatively straightforward. We will have a username, a password, login, whatever we want to include here. We are using some generics. So we are using a subject with a generic of generified into a string or whatever we want. Well, that works very good in Android, but if we were compiling this 4 months ago into iOS and using it from Xcode, we would be receiving this. We would not be able to make an interpretation of that generic. That can be really a blocker, because generics is something that you probably use on your second or third day developing absolutely anything. And it was actually fixed by Kevin Galligan. He's the CEO from Touchlab 4 months ago. So thinking, you need to consider that you might hit some of those problems that are still not well known, and particularly when you are dealing with Kotlin being exported for another architectures. It integrates really well and it speaks really well with Android and the JVM, but in other platforms you hit those problems relatively frequently. Coroutines are single-threaded, not multi-threaded. This is also something that you need to keep in mind when you're developing, especially in the world of the mobile, where we need to use different threads and access the UI from a particular thread, making the networking from a particular thread. This requires a little bit of thinking. There is actually an open pull request in the GitHub repository of Kotlin, where they are discussing some changes that will make the coroutines multi-threaded. But as they are right now, they are like they are. As mentioned, KotlinConf happens in a month, so this thing might change. Some considerations in state. What happens with the iOS developers? I think if, how many people here are Android developers? Can you raise your hand? Okay, most of you. So you're probably happy and excited about this thing because you're like, oh, I already use Kotlin, so why not using Kotlin for Swift and expand my universe? But an iOS developer will probably not be very excited, right? They will be like, why do I have to use Kotlin? I have Swift, even if Swift has their own set of problems, but why would I jump now into another language? Or I face this can mean real difficulty in the real world, right? Because you need to convince teams, you need to change workflow, etc. So this requires working in, well, this sharing mentality where you're doing pull requests, explaining the benefits, maybe showcasing them first in an Android app and see how other platforms would benefit for that. But regardless of your strategy, keep this in mind. Yeah, we are probably talking about the future as well, how this is going to, in which direction this is going to move. Is this going to be production ready at some point? I find it very hard to make predictions in the IT world. I've been developing professionally for 12 years now, and before it was Cordova, there has been like Xamarin and stuff, so there is always like something that is going to be the next thing, and it never really happens. I read this excerpt from here on an article called by a guy called Adrian Kowaczewski, and he says that he doesn't know what is going to happen in 10 years, but there will be people asking in Stack Overflow about regular expressions, and there will be another JavaScript framework, so probably like Angular 10 or Angular 11. He wanted to say that the things keep happening over a lifetime, and sometimes we're trying to find like the problems are always the same, and we're just recreating the solutions. And this is something that happened quite a lot in the multi-platform world. Also, another thing that tends to happen quite a lot, that's my impression, is that when we are using cross-platform frameworks, everything looks very easy. We have a hello world. In Flutter, we have the one where we click in the screen and we increase the counter, and it's very easy, and we all love it, and compiles automatically for both platforms. But in the real world, things are not about having a button where you click and you increase a counter. At some point, an app will have several databases, maybe different APIs that you're connecting, some of them with different authentication, users, a process that is running in the background that needs to update something silently. It gets more complex. My impression is that native frameworks scale much better than the non-native ones. And the non-native ones at some point hit an instant where they essentially get blocked and there is no framework that is able to solve the problem, and they are hard to maintain. All that's at the top of most of them dying within 2 or 3 years. So it's hard to think of any any multi-platform framework that has lasted for more than 3-4 years. Now, probably Flutter is the next thing, right? Many people is probably thinking, well, but what's Flutter? Will Flutter support Kotlin, or Flutter can be combined with Kotlin? Or I'm by no means any expert in Flutter. I think Flutter does an amazing job with the custom UI widgets, and Kotlin is more performant and has a way better ecosystem than Dart and Flutter. There was, in fact, a guy, if you Google something like Flutter, with Kotlin native or Kotlin native with Flutter, there is a guy from Philippines working in Berlin that made a proof of concept doing exactly this, creating the UI widgets with Flutter using some sort of a bridge, and then Kotlin native to make network requests and store them in a database or stuff. And his conclusion was that this is hard. So it might not work. Now, recommendations. Use it with caution. I think it's good to start with shared components instead of going full mental with migrating your entire app. Keep versioning in mind. I would have a hard time recommending any client or any company to use something that is not yet productive, is not yet stable. Something that you can start doing, I did it for a couple of my clients, and it was sharing all the models. Things that I think they bring an immediate benefit are sharing things like a request and responses. Essentially, when we're talking with a backend, we send a request, we get a response. Those things are almost 100% the same on iOS and on Android. And if not, you can extend them or change them with in your local app. And you could maybe have a repository where you centralize all those things, where they get compiled, they get uploaded into a pod or a Maven or a Gradle repository, and you access them directly from the app. That's something that brings immediate value, are just data classes, one line. If for whatever reason you don't want to use them anymore, you can probably script a way to automate them and write them in Swift again. Android can still use data classes, so it's not a problem for the Android developers. Or very small components. Something I did very recently for a client was, well, in an app, normally you end up doing something like a deprecation module, where the app calls a deprecation endpoint, sends the version, and then the endpoint says, you're deprecated, or you're not deprecated, or you need to update. That's something very small, essentially involves one call, and if you want, you can save the result locally with shared preferences or something, but it's something that is very controlled, there is very little risk, and will help you to understand Kotlin native and see if you want to move towards this direction. And of course, never compromise 100% of a project. That, at the current state, would not be a very good idea. There are some further resources to read. I would strongly recommend you to be on the Kotlin Slack if you are not there yet. It's a public Slack where all the members from JetBrains involved with the development of Kotlin are there. They're quite responsive and open. You can ask them any question you have, and they generally make a good work of answering and giving any recommendations. Touchlab resources. This thing over here is their GitHub, but if you Google them, you'll find as well the Medium website, the Twitter from Kevin. They are being very educative about their new findings and developments on Kotlin native. If you allow me some self-expand, Kotlin Weekly, I think it's a great way to stay up to date. And right now we have a lot of content from Kotlin native and coroutines. And well, of course, the Kotlin native documentation. Since it's something relatively new, I find it relatively up to date, and they generally change if they see that there is any problem. But you can learn quite a lot by reading the documentation. They have a few very comprehensive examples over there as well. In fact, if you want to see a real-world application in Kotlin native, you can see the Kotlin Conf app. It's written partially in Kotlin native, and you can see an example of how to have an app that compiles into iOS, Android, web, and has some backend components. And this app actually works, so that's what JetBrains uses for the Kotlin Conf app. Well, that has been everything so far. You've been a fantastic public. If you have any question and I know the answer, I would be super happy to help. Otherwise, thank you for being here. Thank you, Maxime and Mobile Era, for your invitation, and feel free to grab me anytime and drop me any question if you have any. Thank you.